So find a value of each trig function. Again, it's not you can see these values are not from the unit circle. So we want to find the exact value. So again, what we're going to be doing is we're going to be drawing a reference triangle. Now, I don't know why students don't want to follow my advice. When you're drawing a reference triangle, you're always perpendicular to the x-axis. The right angle is always against the x-axis. For example, if you're in quadrant 1, your theta is that central angle there, and the right angle is right there against the x-axis. If you're in quadrant 2, again, in quadrant 2, you're perpendicular still to the x-axis, and there's that reference angle right there. Quadrant 3, again, still perpendicular to the x-axis, you're drawing your triangle right here. Quadrant 4, you're down here. I can't tell you how many triangles in my past I have seen where students will put the right angle against the y-axis. This is a no-no. You do never, ever, ever make the perpendicular against the y-axis. This is a no-no. All right, so everybody see the difference in the way we draw our triangles. You always make the perpendicular side against the x-axis, okay? But I can't tell you how many times students have drawn it against the y-axis. You'll reverse some of your sides of the triangle. All right, so just be careful about that. So part A, these are just simply SOHCAHTOA. Remind me about sine. Sine represents what sides of the triangle. That is your opposite over the hypotenuse. So again, we know it also can be viewed as y over r, but again, they're not giving us the x or y coordinate, they're giving us this fraction. So I know the numerator is my opposite side, the denominator is my hypotenuse. So I'm going to sketch my triangle in quadrant 3. So my hypotenuse is 13, my opposite side, again, remember, sine is negative in quadrant 3. So I know that this side, and I'm on the negative side of the y-axis, so this side is going to be -5. What piece is missing that I have to know? I have to know the other side. Again, I'm going to have to use which theorem to help me find it? Pythagorean. Go ahead and take a moment to find the Pythagorean theorem. If you remember your triples, you won't necessarily have to do the Pythagorean theorem. So you're ready just a minute to find that. So before you get started trying to find your trig ratios, make sure you know all 3 sides of the triangle. And if you don't, make sure you use that Pythagorean theorem. We should have come up with 12. Okay. Again, pay attention to what side of the axis you're on. Notice you're on the negative side of the x-axis. Notice I put a negative sign in front of the 12. That will help remind you to put your negative signs in the correct place. Yes.
So hypotenuse never negative.
Never negative. Nope. It's always going to be positive. Okay. So now you should be able to set up your other 5 trig ratios. So I know sine, cosecant of theta is just simply going to be what? -13/5. Just take the reciprocal of sine. Remember, cosine is the adjacent over hypotenuse by your SOHCAHTOA. So cosine of theta is going to be the adjacent over the hypotenuse, which is -12/13. Well, if I know cosine, I can find the secant. Secant's going to be -13/12. And remember, TOA, tangent is the opposite over adjacent. So looking at the triangle, my tangent of theta is going to be -5/12, which means it's just 5/12. And then the cotangent of theta is going to be 12/5. So any questions on how I've set up my triangle found that third side using your Pythagorean theorem, and then using that triangle to help you find the value of the 5 trig ratios. Everything's either going to be unit circle or drawing triangles. So if it's not unit circle, you know you got to set up a triangle. All right, does that make sense to everybody when you're trying to find trig ratios? Again, location, location, location is key. You can see 3 out of your 5 answers had to have negative signs in there. If you drop negatives, you're looking at -3 just from negative sign errors. Pay attention to your negatives. I can't emphasize that enough, especially for your test on Friday. Okay. All right, let's take a look at B. Now in B, I'm not as nice. I'm not spelling it out for you in terms of what quadrant you're located. So you're going to have to establish your location. That's that trig tic-tac-toe we practiced last class. So take a look at when I tell you that the cosine of theta is less than 0. What does that mean to you? When cosine is less than 0, what does that tell you about cosine? It's going to be what? Negative. So I know it's negative. So right away, what 2 quadrants can I eliminate? Where's cosine positive? Cosine is positive in 1 and 4. So right away, I can eliminate 1 and 4. You got to put the GPSs on. Get your location down. We won't be lost in space. So now, cotangent is 4/3. Well, is 4/3 a positive number or a negative number? Positive. So now use that information to help you narrow down which quadrant you're going to be located. Out of quadrant 2 and quadrant 3, where is cotangent positive? 3. So right away, I know I'm going to be in quadrant 3. Any questions on how I narrowed it down to quadrant 3? So now I'm ready to sketch my triangle. Well, if cotangent is 4/3, what's the tangent of theta? 3/4. And remember by your SOHCAHTOA, tangent's the opposite over adjacent. So then the opposite side is my numerator, which is 3. My adjacent side is 4. Am I missing anything? Well, yeah, besides that. But when I put 3 and 4, am I missing any other critical piece of information?
Negative.
Negatives. Which one should be negative? Both. Do you recognize this triple? So what's that hypotenuse? 5. Again, if you didn't remember that triple, what would you have to do? Pythagorean theorem. So go ahead for me and find the value of the other 4 remaining trig functions. Any questions on, again, once I find that third side and I sketch my triangle, how I can find the value of the other trig ratios here? Any questions on any of these? All right, think about C for a minute, and just in your mind, think about your location. See if you can do your trig tic-tac-toe and see if you can figure out which quadrant you would sketch your triangle, and then we'll talk about it. So remember, when you look at the tangent being less than 0, that means tangent has to be negative. So I know I'm not going to be in 1. I know I'm not going to be in 3 because that's where tangent's positive. So secant is reciprocal of the cosine. So what is the cosine of theta? Then if secant's -2, the cosine will be -1/2. And so again, this tells me that cosine and secant have to be negative. So I know cosine's positive in quadrant 4, so therefore I'm going to have to be located in quadrant 2. So any questions on why my location is quadrant 2? So now remember, by your trig ratios, cosine is the adjacent over the hypotenuse. So I know that my adjacent side is going to be -1, my hypotenuse is 2. See if you can find that third side for me by using your Pythagorean theorem. Do we all end up with square root of 3?
Yep.
Do I need a negative sign in front of square root of 3?
No.
No, why not?
This is in the second quadrant.
Right, because remember, I'm above the x-axis, so I know that all these numbers are positive vertically. So everybody okay on why I don't need a negative there? All right, so then I'm gonna go ahead and find the sine of theta. Sine of theta is gonna be the opposite over hypotenuse. So then see if you can do the other 4 remaining trig functions for me. Yep. Mhm. So how do we make out with that one? Recognize those values? It actually turned out to be a point on the unit circle, did it not? So any questions on, again, so when you're coming to do trig ratios, depending upon the information that's given, you're drawing reference triangles. Remember, I may give you an ordered pair in x comma y. I may give you one of your trig ratios and you have to use that to find the other remaining trig ratios. All right, so any questions on setting up your reference triangles and then finding the other remaining trig functions? All right, some other popular formulas. We've already talked about some back from section 1.5. If you remember last class, when we did our quiz, we talked about those reciprocal identities. So we've already talked about some of our fundamental identities. Remember back in 1.5, we did our reciprocal identities. Remember there were 6 of those. Sine was equal to 1 over cosecant. Tangent was equal to 1 over cotangent. Sine was equal to 1 over cosecant and the others. The other 2 we talked about in the previous section was the quotient identities. Remember, there were 2 of those. Remember, the quotient identity was where tangent was equal to sine over cosine, or cotangent was equal to cosine over sine. Probably some of the most important identities that we're going to talk about or use this year are your Pythagorean identities. And yes, your Pythagorean identities are coming from your Pythagorean theorem, which you know is a squared plus b squared equals c squared. So if you have a point on your circle, I have a unit circle, so I know the radius is 1. We have this point on the circle xy. So I know the horizontal side of this triangle is x, the vertical side is y. So by your Pythagorean theorem, I know that x squared plus y squared is equal to 1, correct? So relating this back to our study from the unit circle, remember x is equivalent to our cosine trig function, y is equal to their sine. So if I take out x into this particular Pythagorean theorem and replace it with sine, that's going to give me a sine squared theta. Plus, if I take out y, that's going to give me a cosine squared, or vice versa. I said it backwards. But there is your first Pythagorean identity. Sine squared plus cosine squared is equal to 1. And again, this is our primary. This is our primary Pythagorean identity. Sine squared plus cosine squared equals 1. There are other varieties because what I can do, suppose I want to solve this equation for sine squared. I could solve this for sine squared, and sine squared theta is equal to 1 minus cosine squared theta, just by subtracting cosine squared on both sides. Yes, Camille.
Does it matter if you put cosine squared and sine squared first?
No, because addition is commutative. Good question. And if I wanted to solve for cosine squared, I could subtract sine squared on both sides. So cosine squared theta is equal to 1 minus sine squared theta. Varieties. As long as you know the first one, you can find the other 2. So for example, suppose that theta is equal to 29 degrees. We know 29 degrees is not an angle from the unit circle. So suppose I ask you without a calculator to simplify sine squared of 29 degrees minus cosine squared of 29 degrees. By now, you're actually plus sine squared of 29 plus cosine squared of 29. By your Pythagorean identity, you're going to be able to simplify this expression because sine squared doesn't matter what the angle is, plus cosine squared doesn't matter what the angle is going to be equal to 1. So as long as these angles are the same, and you have a sine squared plus a cosine squared, you know it's going to simplify down to a 1. Any questions about the Pythagorean identity? Yes.
Does this only work on unit circle?
No, it will work for any angle.
But and it always equals 1.
Yep. Yep. So now there's two other Pythagorean identities. Suppose I take my primary, the sine squared plus cosine squared theta equals 1. And suppose that I take this equation and I divide everything by a sine squared theta. What happens when you simplify sine squared divided by sine squared? 1. Plus, by your quotient identity, what is cosine squared divided by sine squared? Cotangent squared theta by your quotient identity. 1 divided by sine squared by your reciprocal identity is equal to what? Cosecant squared theta. There is your second Pythagorean identity. You may forget what sine squared plus cosine. You may forget 1 plus cotangent squared is cosecant squared. But as long as you remember sine squared plus cosine squared equals 1, which you will because we're going to use that over and over again, you can always derive the other two. Yes.
If it's based on the Pythagorean theorem, then why does it work on like points that aren't points that aren't part of the unit circle?
Because they're dealing with the angles, the ratios are set up so that the angles, it doesn't matter what the angles are, they will work.
So it'll work for like a hypotenuse that isn't 1.
Yep.
But it will equal 1.
Yeah. Yeah. Well, simple. You'd end up like a 5 over 5 or something. That's what it's. Sorry. No, not for these identities to work. So your variations of these, just so you know, your variations. Again, if I was to solve this equation for 1 would be equal to cosecant squared theta minus cotangent squared theta. Or if I was to solve for cotangent squared theta is going to be equal to cosecant squared theta minus 1. Like I said, as long as you know what the second one is that I put in a rectangle, the 1 plus cotangent squared is cosecant squared, you can come up with the other two. But just know you could algebraically manipulate it to come up with other variations of that Pythagorean identity. So then the third one. So going back to my primary Pythagorean identity, the sine squared plus cosine squared is equal to 1. Remember, in the second case, I divided everything by sine squared. Guess what I'm going to divide everything by now? Cosine squared there. So by my quotient identity, sine squared divided by cosine squared is a tangent squared. Cosine squared divided by cosine squared is a 1. By your reciprocal identities, 1 over cosine squared is a secant squared. So there is your third and final Pythagorean identity. Like I said, if you remember sine squared plus cosine squared equals 1, you can come up with the other two. That's why I always show my students that. And again, just like the other ones, you do have your varieties. if I solve for tangent squared theta is equal to secant squared theta minus 1. If I solve for 1 is equal to secant squared theta minus tangent squared theta. Like I said, that sine squared plus cosine squared equals 1 is the primary Pythagorean identity. Last set of identities we're going to talk about in this unit are even and odds. So, and this will apply when we get into the math analysis part of the course. We'll talk about even and odd functions. It doesn't apply to powers. In other words, the confusion sometimes students say is, well, x squared is an even function, x to the fourth is an even function, x to the sixth because the powers are even. Has nothing to do with the powers. It's a relationship of the graph. To be an even function, what has to happen is you're going to have symmetry with respect, and I'm abbreviating with respect to WRT, the y-axis. And when we get into graphing our trig functions in the next unit, you'll see the symmetry that I'm talking about. So what's really I'm saying is this: you have a point, let's say in quadrant 1. I have that point XY. So to be symmetrical over the y-axis, I'm going to take this point, reflect it into quadrant 2. So that's going to become negative XY. Do you agree with that? So even though X is positive in quadrant 1 and X is negative in quadrant 2, the Y values are exactly the same. Do you agree with that?
Yes.
So this is where the algebraic relationship comes from. F of negative X has to be equal to F of X. Whatever the Y coordinate is for X in quadrant 1, the Y coordinate is exactly the same in quadrant 2 as the negative X value. Does that make sense? Just like down here in quadrant 4, if I've got X, negative Y, if I reflect it into quadrant 3, well, X is negative, but Y is exactly the same as it was in quadrant 4. So that's what that algebraic relationship stands for. So then an odd function, it has symmetry, but with this case, it's with respect to the origin. So the algebraic relationship is f of negative x is equal to negative f of x. We'll get into more of the graphical relationship when we get into the graphing in the next unit, but really the only thing you need to know right now is what are your even and odd trig functions. You only have 2 even trig functions. The rest are odd. Cosine of x is equal to cosine of negative x. Its reciprocal is also even. So secant of x is equal to the secant of negative x. Now, how does that help me right now? Cosine of negative 300 degrees. Because you know now that cosine is even, if I'm asking you to take the cosine of any negative angle, you can drop it. So in other words, the cosine of negative 300 is going to be equal to the cosine of 300 degrees. So it makes doing those negative angles maybe a little bit easier. Because what is the cosine of 300 degrees then going to be?
Just did our units.
I know, you just did your unit circle quiz. Come on now.
1/2.
You used up all of unit circles. all the time.
1/2.
It's gone.
We have none left this year.
And if you think about this, if you look at the angle -300, so this will kind of put a picture. Here's 300 degrees down here in quadrant 4, correct? So if I ask you to find the cosine of -300, and again, we know the ordered pair down here is square root 3/2. Excuse me, 1/2 negative square root 3/2. So then if you sketch -300 degrees, -300 degrees lands you where? Up here in quadrant 1. And again, the ordered pair is 1/2 square root 3/2. All right? Does that make sense to you a little bit now? So that's what happens when you have an even function. So now if you have to take the cosine or secant of a negative angle, you can disregard that negative. So it may make knowing those negative angles a little bit easier. The other 4 trig functions are odd. So again, what that means is the sine of -x is equal to the negative sine of x. Its reciprocal would also be odd. The cosecant of -x is equal to the negative cosecant of x. Tangent is also odd. And it's reciprocal. So how does that help me? So I showed you how it helps you dealing with a cosine of a negative angle. How does this help me when I'm dealing with the negative angles of odd functions? Well, let's take a look at the sine of -135 degrees. So a strategy you can use now, by knowing that sine is odd, you can take this negative sign and yank it to the front. So this is going to be equal to the negative sine of 135 degrees. So the sine of 135 from the unit circle is what? Square root 2/2. So now what you can just do is negate this particular value. So you don't have to worry about thinking about what's -135, where is it? So if you think about now why this works, sine of -135, if I was to sketch -135 degrees, it would put me over here in quadrant 3, correct? So I know both the x and the y value are negative. So I clearly know that sine is going to be negative square root 2/2. If I sketch 135 degrees, I know that puts me in quadrant 2. Quadrant 2 is sine is positive in quadrant 2. It's negative square root 2/2, square root 2/2. So I can just take the sine of that value and negate it. So I don't have to worry about thinking about where -135 is. So that strategy may help some of you when it comes to dealing with the exact value of the trig functions on the unit circle when you're dealing with negative angles. All right, so let's take a look at these particular problems here. So here's the tangent of -5π/6 minus the cotangent of 7π/2. And again, these are no calculator questions. So again, if you wanted to use your property of odd functions, remember tangent's an odd function. So what I could do, because this angle is negative, because tangent's odd, what I could do is I could take this negative out and pull it to the front. Negative tangent of 5π/6 minus the cotangent of 7π/2. See if you can simplify that for me. Do you have to? No, but it's just a strategy that may help some of you. So see if you can simplify that. For that one? Okay. Skip B, because we haven't talked about co-function yet. Skip letter B. We'll do co-functions in another unit. Take a look at C. Again, taking a look at C. Well, I don't have my calculator, and I know that 20 degrees is not a value from my unit circle. These are uncommon values. It's an uncommon angle. So that's a red flag that you're going to have to use your identities because you don't have a calculator to simplify this. So take a look at the cosine divided by the sine. By the identities we've talked about, what is cosine divided by sine equivalent to? Cotangent. By your quotient identity, this is equal to cotangent of 20 degrees. So then I can take the cotangent of 20 degrees and subtract the cotangent of 20 degrees. So what is the cotangent of 20 minus the cotangent of 20? 0. So if those angles are not common and you don't have a calculator, that's a big red flag that you're using some of these identities we've talked about. Now let's take a look at D. So D, I see that again, these angles are not common on the unit circle. So when you see these trig functions raised to a second power, that's a red flag that you should be using your Pythagorean identities. Pythagorean identities only work when it's going to be squared. So if you see trig function squared, that's probably a Pythagorean identity. So going back to what we talked about, what is your secant squared minus your tangent squared? It's equal to 1. So any questions on how some of those identities work? And again, what's happening is we're widening, we're broadening how many expressions we can find the exact value for when you have angles that are not on the unit circle. Yeah. We talked about last class. So they're telling you that cosine of theta is 0.2. Find the value of this expression. But what they tell you about cosine of theta, they're telling you that's equal to 0.2. What happens after you go around 2 pi? What happens with all these values? They repeat. So then what's the cosine of theta plus 2 pi going to be equal to? So what's this value going to be? It's also going to be what? 0.2. Plus, if I go around again, if I go down once, it's same. If I go around a second time, it's also going to be the same. So what's the cosine of theta plus 4 pi? 0.2. So 0.2 plus 0.2 plus 0.2 is just going to be 0.6. Remember your periodic properties. So remember, cosine is repetitive after 2 pi. So no matter what this angle is, if I add 2 pi to it, the values are going to be the same. Yes, just 0.6. Because they've already telling you if I've replaced cosine theta with 0.2. So think about from the unit circle for a minute. We know cotangent is the reciprocal of tangent. Think about from angles between 0 and 2 pi, where is cotangent undefined? Think about it for a minute in your head, then we'll talk about it. 0 in the denominator. So we know to be undefined, we're looking to see where is y equal to 0. So on the unit circle, we know we're dealing with a quadrantal. So in the unit circle, where is cotangent then going to be undefined? It's going to be where your y coordinates are equal to 0. So it's going to be when theta is equal to 0, right? Where else? Where else is cotangent undefined? Where else is your y coordinate equal to 0? Kimmy? Or in radians, it's going to be pi. Where else? 2 pi. Keep going. 3 pi. Where else? 4 pi. Where else? 5 pi. 6 pi. 7 pi. 8 pi. I could keep going, couldn't I? So really, it's going to be undefined when I take pi and multiply it by some integer, correct? Any multiple of pi is where cotangent will be undefined. 0 pi, 1 pi, 2 pi, 3 pi, 4 pi, a million pi. Cotangent will be undefined.